here that's, this one in particular is about 13 volts and 5 amps. You can also use something that you have in the house, which is this one. This one is 12 volts as well, but it's only about 1 amp, which etches a lot slower. What I've done is I've cut off the ends, so I've got exposed wires. I separated them, worked out which one's positive and negative. In the bath already I've got a piece of aluminium which has a resistance on it. And for this example I've used vinyl, but you can use anything like nail varnish, anything that's going to cause a resistance to the current going through it. I've seen that you've been using P&P paper as well as a resistant. The advantages of this is that you get a nice crisp line.
Is that a picture of Pinky Promise or something?
Aye, it is.
Right, yeah.
I've got a few examples. That's the vinyl I use, and I've got a vinyl cutter at home. So there's a bunch of stuff there, and I've done patterns as well. But the P&P paper doesn't always transfer onto the metal very nice and neatly, so sometimes you have to go over it in pen to clean it up. It's important to get the current going in the right direction, so I've got a piece of wire which is a negative that's just going into the water and no more, and then I've got a positive, and the positive is actually connected to the plate in the water. It's important to cover up anything that you actually don't want etched. The less surface area to be etched, the better, because it'll engrave faster. Because this is quite a large power supply, it etches faster, but it causes bubbles on the surface, which when it's etching causes little shadows. So if something's been etched really fast and really violently, it will cause little circular bubbles around the outside. So if I turn this on and off, you'll see how violent this one is, and you'll see that the actual aluminium's eating away quite fast, and you can see that because the water starts to change colour, and that's the material being lifted off the metal. So it's quite important to, you can use like higher voltages and higher amps, but you need to keep brushing off the bubbles so that you get quite an even etch. So I'll just leave this one for a few seconds, and I'll just keep brushing away the actual bubbles, and the water gets mucky, but you can keep reusing the same water, and all that is water with salt diluted into it, and it's basically water can only hold so much salt. So if you keep mixing in salt until it stops dissolving, so you can still see a little bit at the bottom, you know you've got as much salt as you need in the water.
Is that cold water?
It can be cold water, but I find that if you use warm water, it helps break down the salt faster. It's like when you mix your cup of tea, you put sugar in it. It's, I've done it once actually. It does break down the salt a lot faster if it's warmer.
What is the gas that's coming off of the bubbles?
It's just a chemical reaction between the salt water and the metal. I would advise doing it in a well ventilated area, but it's not going to kill you.
Oh, that's alright then.
Damn!
Turn it off so you can see what's happened.
That's really quick, isn't it?
And depending on what metal you're actually etching, it'll change different colours. So if you're doing brass, it'll go a brown, a pinky colour. You see it's where it's changed colour, you can see how deep it's actually etched. So it comes off in layers, aluminium, so you can actually see how deep you're going. So it's actually etched deeper in one area than it has the other. To avoid that, I would move the wire around occasionally so that you get more even coverage.
What colour is that? It's just some paper which one's
The aluminium,
so it's a silver, right?
it's just,
Oh no, that's aluminium. It's got coloured aluminium with just etched through fine aluminium colour.
Oh, let's get the final.
you see underneath I've got the positive wire, and that's connected to the bare surface in the bottom, and then I've used electrical tape. And you want to just cover it as much tape as possible so that this wire doesn't actually touch the water. It should only be touching the metal, because you'll cause a short circuit otherwise.
Would that work about the same speed in copper or silver?
They break down a lot slower, but the advantages of using quite a large voltage current means it doesn't really make a huge difference. But if I was to use this one, it would make a drastic difference. This time I'm just going to put it back in a different place so that it's...
What about putting the wire in a ring shape?
You can, but I find that you're causing too much surface area. If you use too much metal in the water, it's more likely to cause a short circuit. So if you put it in the water and it's not doing anything, it's likely that to be a short circuit in the waters. You need enough water as well. If you don't use enough water, then it's basically going straight through to the metal.
Do you try seeing if it just lifts the colour off the bits that are bald, if you know what I mean, but not all of it? Because that would be like laser etching.
Yeah, we can.
There's more of a drastic difference. You'll see it's more lightly on one side than it is on the other side. And you can sometimes tell that you're not dissolving enough salt into the water if it's quite patchy, and you can actually see like granules on the surface. So from this I can see that that's quite even, and that's what I want all over, and this bit here needs to be etched deeper. When you're prepping your metal, it's important to have clean metal, so if you rub it down with an abrasive block, like the Gary Flex blocks that I've got in there, or even wool, it's important not to get your oils from your hands on the surface, because that will affect the etching as well. And I think it's the same when you're using the acids in here, that you want to prep, do as much prep as possible beforehand so that you're not having to go back and etch stuff again. When you look at examples online, you'll see that some people use metal plates. So what they'll have is two plates in either one line on the bottom and one line on the top, so they're on the same plane, or one going on one side and one going on the other side. The reason because some stuff you need a larger area of, I call it a sacrificial piece. So there's a piece, I typically use aluminium or stainless because it doesn't rust, so you can use it again and again. But if you use something like mild steel, you would have to clean the rust off in between each use. I find that this voltage and just having like this negative wire just going into the water is enough surface area that it causes the etching to be there's sort of a decent speed, and the surface area is small enough that it doesn't cause the actual short circuit that I was speaking about earlier. If I were to increase this, or even use something like this that I've made before, like the ring shape that's too much surface area. So what I had to do was just plonk like slight, just one edge into it, because that was just enough. What I could do is I'll remove this mask so you can actually see what it's done. So that's all that is, that's just a positive wire that I always use red because I know that's the same one every time, and that's what one will go to this back plate. So that was quite a short amount of time, but if I had spent longer then I would have got a lot deeper etching. When you're using acids in here, I noticed that it dirties up the metal a lot more as well. Where if you're using vinyl, nothing's in contact with that surface, so it's basically as you put it in it, it's the way it comes out. So what I had here was just a sheet of aluminium that I had orbital sanded with a hand sander. So that's basically what I've got out of it, is just exactly how I put it in it, and the only thing that's changed is the bits that weren't masked. And I pass it around so you can see how deep that's etched. I suggest if you're doing something a lot smaller, say if you wanted just to put a signature or your own mark onto a piece of jewellery, that instead of using a bath, you just take a metal plate, put the positive on the back, and the negative, just take a Q-tip, connect it to the Q-tip at the end, and then dip it in salt water like this, and then just either clamp it on the end or wrap some wire around it, and then you're basically completing the circuit. So you've got the positive there, negative in your other hand, and you're just touching the two together, and you'll see it fizz. I find that really beneficial when I'm doing really small stuff like signatures, because I control exactly where I want to etch and how deep I want to etch. So if you were just to put font, I've made plaques for people. It's just basically text that the customer's chosen, and I've basically polished up a piece of metal with that text etched into it, and I've just carefully went over it, and then because I can remove the mask, all I do is go over the Guy Flex blocks. I've also got stuff like metal polish I use, buffing compounds, and then I just take off the fine, it's like a fine grit to the aluminium that I've just etched, and you can basically remove that with wire wheel or the abrasive blocks. And once you've polished it up, it's basically, it's different from the etching that you would get from the acid. It's a lot cleaner. I think it's a lot quicker as well. The thing is, you have to keep monitoring. You can't just leave it for a long time, especially with higher voltages, because you'll have to keep brushing it off.
You don't brush it off, does it give you a, then give you a sharp edge, you know, it'll give you
A bubbling, yeah. So you won't get a crisp line, you'll sort of get a line and then bubbles.
right.
It's kind of like if you ever mix a bit of liquid water and paint and blow it onto paper, you'll get like outlines of bubbles on the paper. It's basically the same as that. It's causing too much resistance for the current to get through. So within a space of like 10-15 minutes, we actually got something that would took acid a lot longer, and your clean-up process and your pickling as well. Once you've added it all up, makes a big difference.
How deep could you go if you wanted to use it for enamel?
You can probably go quite deep actually. You've got to find the right balance between time, current. Got to keep monitoring as well, I guess. I've heard people went through thin stuff, maybe like 0.2 or 0.3 mil stuff. Yeah. Scrap stuff in there, that stuff there wouldn't take very long to go through that. If you see how deep that's went already within a few minutes. Yeah. I think that's 2 mil maybe.
One side.
Even that looks quite nice, but when you've polished it up, you'll get a subtle difference between the top surface will be sort of a glossy, shiny, and you'll still get a sort of matte finish to the bit that you've etched.